Good morning, everyone. Just as people are filtering, morning, everyone. Just as people are filtering through, just like to quickly extend a very warm welcome. And we're very excited for the launch event for the Genomic AI Network of Excellence this morning. I think we have a great run of speakers, and we're very excited to give us an overview of the session itself. So, my name is Wesley Pig. I'm one of the project managers for the Genomic AI Network of Excellence. I will just very quickly give you a run through what we plan to do today, and then we'll crack on into the speakers, which is the much more interesting aspect of the session. So maybe the caveat is I won't be able to do any of these speakers justice, so I won't fully introduce themselves. I'll let them do that. But a quick overview of the session. So we've got Debbie Porter from the Genomics unit. We're giving us an overview of how the Genomic AI network fits within the wider NHS. This will then be followed by our network director, James Dickinson, who will kind of give an overview of the Genomic AI network itself. And then this will be followed by two sessions with work package leads for work packages that actually fit within the Genomic AI network and are doing active works and projects within it. So the first session will be by Sarah Ennis, Professor of Genomics at the University of Southampton and the Research Director for the Central and South Genomic Medicine Service Alliance. This will then be followed by Antonio de Marval, who's a senior lecturer at King's College London and a consultant cardiologist at KCH and Guy's and St. Thomas. So that will wrap up the exemplar work packages section. And then we also have Claire Anderson from Unique Charity, who she is the Scientific Communications Officer, and will kind of be giving us an overview of how PPV fits within patient and public fit within the Genomic AI network as well. So a lot of exciting work. And then finally, from a speaker's perspective, we have our clinical lead, Alexander Deng, who will be giving us an overview of how to get involved, how you guys get involved, and next steps from today. And they will all then be wrapped up in a Q&A session to end. So that's the overview of the session. Really excited. I will crack on. Actually, no, I won't. I will be the boring one and give some logistics for the day quickly. So cameras and mics should be off for the session. And then if you could post any questions, please do in the Q&A chat, and we will collate these and try and get to them at the end of the session. We couldn't turn off the function to avoid people raising their hands, but ideally what we'd like to do is let the speakers finish their flow of their sessions, and then we'll collate all the questions in the chat and answer these at the end. And then just as FYI, the session is recorded and it will be going on YouTube just as a kind of a snippet so that we can kind of use it to show people what the Genomic AI Network of Excellence is. So we're very excited. I will kick us off. So Debbie, I believe you are next on the agenda. So I'll stop sharing, and I think Tasnim, I think you're sharing from here.
Thank you very much, Wesley, and good morning, everybody. It gives me great pleasure to be here on behalf of Sue Hill, the Chief Scientific Officer, who is the Senior Responsible Officer for Genomics in the NHS. So just to give you a little bit of a background of who I am, I'm one of 3 Deputy Directors in the Genomics Unit, part of NHS England, specialised commissioning. And my responsibilities include all things data and digital within a transformation portfolio. So I'm here as the unit sponsor for the AI Network of Excellence, and looking forward to all of the great work that looks like it could be burgeoning in the future. Next slide, please. So I wanted just to give you a very quick grounding and context about how NHS England and the Genomics Unit, the Genomics Programme, are supporting a number of networks of excellence to undertake this work, and why we've commissioned this activity to go ahead. So first and foremost, the landscape in the UK is what makes implementing genomics medicine possible. The UK is one of the world leaders in terms of genomics medicine, particularly in a healthcare setting. There are other countries that are ahead in terms of research and development, but in terms of implementation, we can really say that the NHS is world leading. And we are world leading for a number of reasons, and because we have built on the back of one very large program, the 100,000 Genome Project, and we started work in 2018 on implementing the Genomics Medicine Service on the back of that project. So currently there is an awful lot of support for genomics, and it's seen as a real disruptive science within healthcare, and it could really impact on the development of healthcare in the future. The key factors of support are that we have got a large research and innovation network, that genomics can be used across the NHS and with other organisations such as the UK HSA, for example. We're working with quite closely on genomics projects. We have the opportunity in the NHS, because we're collecting large data sets, to be able to enable industry to work with us. And the AI Network of Excellence is going to be instrumental, I think, in enabling us to do that on these large data sets. But most importantly, I think we've got the political and the healthcare system will to be able to support the development of the Genomics Medicine Service, underpinned by a number of really big strategic changes and visions, including the Office for Life Sciences, DHSC and Genome UK, and the NHS itself, obviously. Most recently, the Secretary of State for Health and Social Care has basically said that the government will make the UK a powerhouse, a technological powerhouse for life sciences and medical. And the NHS and genomics specifically is called out here is the best place to do that, we think, in the world currently, or it has the opportunity to be. Next slide, please. So we published in 2022, October 2022, a 5-year strategy for delivering genomics in the NHS. And that includes 36 commitments that are closely aligned with those strategies that I mentioned earlier. I mean, and there's an additional one there, just the UK Rare Disease Framework. We've got the vision that we will be projecting, preventing and diagnosing disease in 5 years' time, and targeting treatment for specific diseases. So we will accelerate the actual implementation of genomics medicine across the NHS over that 5-year period, and making sure that we can deliver both an equitable service and a world-leading service to inform population health as well as individual direct care. The strategy is built on 4 pillars. Pillar 3 is the one that is really closest to my heart, alongside pillar 4, which is enabling genomics to be at the forefront of the data and digital revolution. And the NHS may be accused in the past of being a little bit analog, and there is a government initiative now to move the NHS more into the digital world. But we're not just moving into the digital world, but we're actually accelerating into the digital world, and the use of AI would be actually instrumental in that acceleration process. And then closely engaging with priority 4, which is evolving the service through cutting edge science, research and innovation, which is exactly what the networks of excellence were set up to do. Amanda, a little quote from Amanda there, talking about genomics in respect of it's one of the most exciting opportunities for medicine, and that the disruptive change that may result from this opportunity. We have actually crystallized that in the strategy, so I can recommend that strategy to you for a short read. Next slide, please. So just a little bit about what the Genomics Medicine Service consists of. It's quite a greenfield site in terms of other diagnostic services. It's structured in and around 7 regions, not quite aligned with the other NHS regions, but close enough. So we've got 7 genomics laboratory hubs who generate the data, and they act as the hubs for a number of local genomics laboratories within their regions, and 7 genomics service alliances, and they are the powerhouse for mainstreaming, for developing new pathways for genomics to be used in clinical practice. And we work alongside obviously clinical genetic services and other diagnostic services such as pathology networks, and particularly in the cancer area. But we do have a development partner called Genomics England, who again we work in development with, but we also work as a service provider in terms of the bioinformatics. And I'm going to go into a little bit more detail in the future about how our digital and data developments are working with Genomics England. And then we also work alongside an NHS Genomics Research and Innovation Collaborative to deliver some of those benefits that you'll see along the bottom there. We've got some particular drivers in the strategy, including things like the introduction of pharmacogenomic testing, and we've got a particular focus in cancer in the next couple of years, enabling earlier diagnosis and enabling patients to live longer. Next slide, please. Okay, so how does this work? We try and we are a learning organisation. We're a learning health system, and that's what we are trying to do. So in terms of discovery work, optimising of proof of principle, translation of research into clinical trials, and then embedding that into routine care. So the genomics unit is the commissioning unit and the decision maker and the funding provider for any of the projects that actually prove to be of benefit for patient use in the future, and we have a way of many levers for embedding innovation in that work. And I'm going to quickly move on because I think I've probably got a couple more slides that I need to get in the next 3 minutes. Next slide, please.
Debbie, it's okay. Yeah. You got a bit more time if you need, so feel free.
Thank you. In that sort of discovery space, we've got researchers and Genomics England. The Genomics England team have got access to de-identified data in something called the NGRL, which is the National Genomics Research Library. It is a large data set, which we could potentially use for training AI tools in the future. However, it is just whole genome sequencing, and whole genome sequencing only represents about 5% of the activity that the Genomics Medicine Service do. So the opportunity for collating more data, standardizing more data, and connecting more data is there. And we are sure that the AI Network of Excellence is going to help us do that. Not just prospective data, but retrospective data as well, as we search existing electronic patient records for phenotypic and genotypic data. So yeah, actually we can move on. Yeah, that's fine. No worries, we can move on. Next slide, please. Yeah, that's great. One of the reasons why research is slow is that we have got many barriers to unlock. And one of the reasons that we think we can unlock those barriers is because we are a small, coherent, and very self-supporting network of networks. So we are what we would like to do is work together across each of these networks of excellence, and I'll introduce you to a few of them in the future. But essentially, I think AI has got an opportunity to influence and help grow many of the other networks of excellence plans. And accelerate the outputs of that research and translational research, more importantly, into a real practice in the NHS. And the way we do that is we are a very close-knit network, and we can avoid those duplications by sharing information and sharing support across the networks. Next slide, please. So these are currently the 8 networks of excellence that we have funded and have kicked off. So we have a prenatal one based in and around the good work that that Gosh has already started, circulating tumor biomarkers in the approach to testing for cancer in blood, so a blood sample, hematoecology. We're trying to get whole genome sequencing into and whole exome sequencing into hemato-oncology quickly to really accelerate the time taken to bring a treatment, an appropriate personalized treatment to patients. patients. Rare and inherited disease, there's a massive opportunity there to use data to connect many of these small groups of patients with particular rare diseases. There's an infectious disease one, which has just been funded to a greater extent by the Treasury to involve a biosecurity response, so something that we can prepare in advance of the next pandemic potentially. Cardiovascular disease, again, connecting data and patients with potential clinical trials. Pharmacogenomics, I mentioned earlier, as a new way forward, but this has got a large digital element to it, and to be able to present a pharmacogenomic profile at the point of prescribing is what we are trying to do with patients in the future. And then obviously the one you're here to listen to and hear all about, the AI Network of Excellence, where we potentially will be connecting all sorts of data that have sat in silos previously and using the power of AI to interpret them more quickly and more effectively. Next slide, please. Okay, so where are we at in terms of the data and digital vision? So this is the now is probably around about 12-18 months ago, but we've still got quite a lot of unstructured data in there. So we have got an opportunity to start structuring the data so that we can actually utilize AI. And there's a number of projects in flight at the moment to be able to do that. We do not have a connected system yet, and there is a lack of adherence to national standards. So we've got, in order to scale the benefits that genomics can deliver for the community, that we are attempting to connect those data sets, to link them together, to have the power of the scale of the data in order to be able to utilize AI to be able to do it. And we've got 3 big projects doing that. The bottom one there, the Unified Genomic Record, which will provide a single point of access to these data with a single patient record, which we can potentially utilize in the future. All of it is going to be based on a digital structure and architecture that is a nationwide architecture based on standards using FHIR standards. Okay, I'm going to move on quickly. So how does that all fit together? So this is the proposed infrastructure components. I'll just call out a few elements of it. So that unified genomic record I've mentioned in the future, which is the concept about how we are going to link those data, not necessarily put them all into one database, but be able to link them and search them. The hospital patient record system is where a lot of the information sits at the moment, but each of them are siloed. So the idea is that they're going to be linkable through this unified genomic record, and we can then potentially search them. The GMS compute service is another opportunity for AI to use the actual raw data, the sequence data, and we will be developing a series of master bioinformatic pipelines within that GMS compute service, national compute service, in the cloud, including sandbox environment where Genomics England, NHS, and industry can collaborate to develop bioinformatics pipeline. And we are standardizing, growing that data set sufficiently to enable the training of AI, and the scalable technology is underway at GEL currently to enable that to happen. And the NHS is pushing forward with a parallel set of work, which we will be merging in the future. Next slide, please. So in summary then, we will continue to work together across the Genomics Medicine Service and across the 8 networks of excellence over the course of the next 18 months. The NHS Genomics Unit will be reviewing the outcomes at the end of each year to ensure progress and to inform, which is exactly why the networks were set up, future commissioning decisions. So there is an intent to actually commission some of the work that comes out of these networks. And today is an opportunity to hear about the progress to date, as well as the challenges and the opportunities, and to get input from all of the audience, hopefully to support the really good work that this network is doing.
Amazing. Thank you, Debbie. And I realize we set you an incredibly difficult task to summarize everything that's going on in 10 minutes. So really appreciate that. Just a reminder to everyone in the audience, please do post any questions in the Q&A session. We will do our best to get to these at the end of the session. But yeah, I'll hand you over to James. Thank you again, Debbie. Thank you.
Thanks, Wes, and thanks, Debbie, for that excellent introduction to the work of the network. I'm now going to spend a few minutes kind of going through in a bit more detail what exactly it is we're trying to achieve and why. So I won't dwell too much here because we've already heard from Debbie about the different AI networks of excellence across genomics. I think the one thing I would add, though, is that the AI network is somewhat unique in that it kind of cuts across the work of all the other networks. So our intention is to work with all the networks of excellence because we kind of believe there's probably kind of AI-driven use cases across all 7 other networks of excellence, and that's work we've already started, but we're kind of keen to develop that throughout the lifetime of the network. I thought that I'd start by maybe starting to kind of explain by what we mean by AI, as I think that's kind of one of the first challenges that we face within the network is the kind of the general kind of state of understanding about AI is quite mixed. And so I just picked 3 diagrams that I found on Google, which attempt to kind of set the scene for what AI means. And I thought they were quite, illustrative in that, first of all, you can see there's no agreement here about what AI means. Each of these diagrams attempts to show AI alongside other kinds of sort of like data science workflows, and they're all different. The second thing is that kind of overlap is that AI doesn't exist in a vacuum. AI overlaps with a lot of other kind of things such as kind of data science and data analytics. And so for us, I think what we think is that, really, we're not trying to be too prescriptive here about where AI kind of begins and ends. We are interested in all these kind of things that I put on the screen here. And really kind of it's about kind of the utility from AI. We're not so interested in kind of, being so rigorous about definitions. We're more interested in kind of the impact we can have from AI. And so what does that kind of look like maybe in other spheres in the NHS that are perhaps further along the kind of AI journey? So I've just picked 3 here as an example. So radiology is probably one of the best examples of AI in use in the NHS to date. It's been around for quite a long time, probably over a decade or so. And the example I picked here is decision support. So where you're using scans from, say, X-rays or MRIs and using an AI tool layered on top that kind of provides support to a radiologist who's interpreting that image. And the intention here is obviously that we're improving patient outcomes by making it easier to identify risk. The one in the middle there, automated note-taking, much more recent. These kind of workflows are driven by tools like ChatGPT, and I know that across the NHS, there's a desire to improve productivity. And this is a really simple example where even if it's just something like a back office set of meetings, using kind of large language models that can actually kind of take a transcript from a Teams call, turn that into a set of notes with action items. That kind of technology has been deployed over the last 12 months in the NHS, not so much in the kind of clinical facing world, but certainly in the back office. And the third one I pulled out here is DNAs. And this is not the DNA from the genomics world. This is DNA as in did not attend. So this is where patients often don't attend appointments for a variety of reasons. And there's a couple of tools out there which have been built using machine learning and other AI techniques, which allow us to kind of look at data sets to understand exactly what kinds of patients are likely to miss particular appointments, and then to intervene and maybe kind of to allow those patients to actually kind of attend. And that's, obviously designed to improve resources across the NHS. So all 3 here are quite different uses of AI, not specific to genomics, obviously, but the kind of the principles still apply. We're very interested in a kind of very broad set of ideas. And so where does that apply in genomics? So I've got on the screen here an incredibly simplified version of the kind of clinical pathway for genomics, from starting to identify patients at the beginning through to ongoing review at the end, clinical trials. And for each of these, I won't dwell on this. I've got an example of how AI might be used at those phases. And we're going to hear about 3 of these later today from our team. So you can see that we're really interested in an incredibly broad set of problems, an incredibly broad set of solutions too. So once again, we're not looking at one specific part of the clinical pathway of genomics. We're interested in the entire thing end to end. So then why does the network need to exist? What's the problem when it comes to AI genomics at the moment? So what I've got here is a survey that we commissioned earlier this year, where we went out to the genomics community across England and asked them to come back with their thoughts on AI at the present stage. And you can see in the bottom left, I think that's probably the most interesting kind of stat I've got for you today, which is that currently AI usage is actually quite small. Only 29% of people say they're currently using AI, and we'd obviously like that to be higher. And why is it the case that it's not higher? Well, you can see here that there's a huge number of barriers to adoption that were highlighted by our respondees. So education and training is a big one. Actually kind of having the time to kind of think about AI is another big one. And then there's a whole set of kind of ideas around the kind of the readiness of the workforce and the culture, resistance to change, not really understanding where these tools would fit in. And I think that kind of then goes into the people's confidence too. And this diagram here shows the kind of the relative confidence of people in understanding, how they might go about deploying AI, what the kind of requirements would be and what products would be. And you can see the kind of the less confident cohort in my red ring is much bigger than the somewhat confident cohort in my green ring. So approximately 2/3 to 1/3 here. People just don't really know what they ought to be doing when it comes to AI. And that's one of our kind of the key things we want to address. So I'll skip over that and actually kind of get on to what exactly is it then that we think the AI network is going to do. So if we kind of boil it down to kind of these three core points, the AI network hopes to identify solutions within genomics, which are kind of have a kind of AI-powered solution to them. Those might be tools that already exist, products that already exist on the market, but that we're not currently using the NHS. Or it might be the case that we can see there's a particular problem in genomics and we think there's a good solution that's likely driven by AI. Where we've identified either these problems or these tools, we then want to evaluate them. So the network has its own funding and we're running some of our own pilots, but equally we're really keen to understand what else is going on outside the kind of periphery of the network, either within the NHS or beyond, and to understand where those tools are actually proving to be beneficial and what the kind of cost benefits to the NHS would be to use them more widely. And then finally, where we think there is a kind of a good solution that should be used in NHS, we want to help scale it. That could either be at a regional level or a national level, but it's all about kind of ensuring that those kind of beneficial solutions actually kind of get used more widely. And that then lastly kind of aligns to kind of the core way we've set the network up. So these numbers 1 to 4 represent the different kind of core goals we have within the network. So the first one's quite simple, actually kind of building the network itself, building community within the NHS and beyond, hence why we're all here today. The second one is actually kind of to pilot solutions, but also to identify other pilots that exist outside our network. The third one we'll hear a bit more about, like you said, which is actually kind of building a toolkit. So when we understand a bit more about the barriers to adoption, we help to try and address some of those, actually lower the barrier to entry when it comes to using AI in the NHS. And lastly, it's really critical to us that patient and public engagement is at the core of everything we do. And we've got a separate work stream that's looking at that. And I think that is probably where I will finish. And hopefully some of my colleagues will now go into a bit more detail about some of our sub-work streams.
Wonderful. Thank you so much, James. That is totally correct. We have Sarah Ennis expanding on one of our use cases at the moment. Sarah, I'll pass over to you.
Lovely. Thanks, Wes. Can you see and hear my slides?
Yes.
Hear me? Lovely. Great. So thank you very much for inviting me today. So I'm here to talk about what is less glamorously known as Work Package 3B2, but we also know it as the GenePy project. But before I go into the details of that, just to let you know that my interests are actually across large-scale genomic sequencing data sets applied to research and diagnostics over the last few years. So I've also have interest in data sharing, governance, standardization and the use of large language models. But the purpose of this talk here is to talk about just one tool that we've been involved in generating over recent years and how we're using that as a project within the GAIN network. So the problem, as I'm sure most people here know, is that genomic data are absolutely vast. They're incredibly sparse, and I'll talk a little bit more about that in a couple of minutes. And they're increasing. So as we sequence more and more individuals in England, across the UK, and across the globe, this problem is increasing all of the time. So I think everybody knows if we conduct a whole genome sequence on any individual patient or trio, for each individual, we observe about 5 million single nucleotide variants, another 600,000 indels, and even more structural variants across a large landscape of the genome, summing to almost about 6 million variants per individual. So this is a vast, vast amount of data. And the issue is that as we sequence more and more people across more and more wider ethnic diversities, we actually observe increasing numbers of rare, very rare, and private variants. And many of those private variants are of uncertain significance. We haven't observed them in other individuals. Now, these rare variants are important. They're known to have very often larger clinical effect sizes, so we absolutely can't ignore them. But that means that as the data get bigger and bigger and bigger, they become more sparse and less modelable, less amenable to AI tools and algorithms. And they demand more and more manual curation in order to review and interpret these ever-extending lists of variants across genes of interest. So although we might be used to A, T's, G's, and C's on the bioinformatics pipeline, we end up with these really, really sparse matrices where you could imagine the rows in this matrix here represent individuals and the columns represent variants. So as we sequence more and more individuals, we add on many, many more variants. But of course, those variants are observed in very, very few people, those new variants. So it's an increasingly vast and sparse universe of data. And we have to do something to try and address that, to try and compress the data so that we can actually make intelligent sense of it and interpret it. So that's where the GenePy tool comes in. It's a pipeline, a tool for pathogenic signal compression. So it's a data reduction tool that aims at achieving better genotype to phenotype based diagnostics. So it reduces the dimensionality of data such that we're no longer looking at individual rare or very rare or private variants, but we're looking at burden of mutation in individuals in across all genes. So it rescales vast genomic data, which are currently very often represented as variant call files at the variant level. It rescales it so it's at the gene level. So there's an upper limit of how many columns, if you like, we generate in that matrix, and that upper limit is the number of genes in the genome. And this sort of matrix, this transformed data, obviously it's scaled at the same level as transcriptomic, proteomic, and metabolomic, other omic data. Therefore, it lends itself to multi-omic analyses and machine learning modeling. I don't have time to go in great detail, but as a very brief summary, this is how it works for one individual one. Up here, we have this one patient and we have gene A, so any gene. And this specific individual has 3 variants in this gene. For each of those variants, we take a measure of deleteriousness or pathogenicity, and we use the most recent version of CAD. We take the allele frequency from public repositories such as Nomad, and we take the zygosity of that variant observed in that individual. And we use an algorithm to combine these bits of biological information into a score for that variant for that individual. And then for all the variants in that individual, we create the score and we sum to end up with one single number that is assigned to that individual for that gene. And then the next individual 2 comes along and they may have 16 variants and they're all completely different to the variants we observed in individual 1, but we end up with a score for that individual as well. And it iterates through large cohorts to generate a score for all individuals for all genes. So we end up with a matrix that looks a little bit like this. And so it enables this pathogenic score, an intuitive score, whereby a large score means a large pathogenic burden in a given gene. So it means you can take any individual and ask across their entire genome, across their profile of genes, where does that individual have a high pathogenic burden? And does that gene align with their clinical phenotype? Similarly, you can actually reorder or look at it from the opposite perspective, and you can take your particular gene of interest and rank the scores for all individuals, and then go and ask, well, in that gene of interest, do the individuals with a high burden of scores have the phenotype I expect? So we can reverse the paradigm and not always go from phenotype to genotype, but sometimes from genotype to phenotype. And as I say, input these data into into machine learning models. So the aim of the GenePy project is to implement this genomic variant signal compression algorithm on a large scale in genomic medicine data to provide proof of concept that it actually acts as a tool that can improve diagnostic uplift, especially for patients perhaps where the diagnostic report has already proved negative. We can assess the potential of this tool to work as a first pass to try and alleviate the manual curation burden. We all know there's a bottleneck. We have a systems level solution to generating genomic data, but we need some systems level solutions to interpreting and analyzing these data and alleviating that manual curation burden fallen to the clinical scientists across the country. And then we want to test the implementation on prospective data in collaboration with the Genomic Medicine Service, Genomic Laboratory Hub partners, and of course with Genomics England. So our progress to date, we've actually published some preliminary findings. That paper has just come out showing the sensitivity. That was adapted on a very early version of the GenePy tool applied to a subset of genes in Genomics England, but where it already identified about 122 misdiagnoses, and they were fed back on bulk to the diagnostic discovery group within Genomics England. We've updated the software. Genomic data are constantly evolving. Initially, GenePy was developed to incorporate biallelic variants where we observed a reference allele in the human genome, and our patient data may have one alternative allele. But of course, as we sequence more and more people, we observe multi-alleles at many sites across the genome. And now the GenePy software can incorporate those multi-allelic variants that we're increasingly observing. We've also updated various annotation tools and modified the QC workflow. This is a very data-intensive algorithm initially when you're applying it to, for example, 100,000 genomes in Genomics England or 500,000 genomes in the UK Biobank. It's quite intensive, so it's critical that we optimize the efficiency of the actual pipeline and the algorithms. So we're wrapping that up in a Nextflow wrapper and modularizing the sections of the data processing to make sure it's as efficient and cost-effective as possible. We're now in the process of generating a matrix for 200,000 UK Biobank participants, and we're looking at the performance of the metrics within that cohort at the moment. And as I say, we're optimizing the testing of the Nextflow specifically for the GEL research environment to be tested across the chunks that the genome is now split into, almost 1,000 chunks in the 100,000 genomes data and the Genomic Medicine Service data that are already sat in there. So that's our progress to date, and my timer's gone off, so I'll hand back to Wes. Thank you.
Amazing work. Thank you so much, Sarah. And thank you to everyone who was posting questions in the chat. Some very interesting questions coming through. So please keep doing that as well. But thank you, Sarah. Very interesting to hear what you're doing, and great progress, of course. I believe we have Antonio next. So Antonio, are you able to share your slides? Perfect.
All right.
There we go. Can hear you now.
So you can hear me and you can see slides.
Correct.
Perfect. Right. Lovely to meet everyone. My name is Antonio. I'm a cardiologist and a senior lecturer at King's, and my clinics are at King's College and St. Thomas's. I'll talk to you about AI at the other end of the spectrum from Sarah. Work package 3C, as it's normally known. The goal is to use AI tools to improve the care of patients with inherited cardiovascular conditions. Inherited cardiovascular conditions is an umbrella term to quite different and individually rare conditions. At one hand, we have channelopathies or things like Brugada syndrome and long QT syndrome, which are mainly diagnosed using ECGs and are strongly associated with the risk of sudden death. Then we have the biggest cohort, which is heart muscle disease, so diseases that affect how the heart contracts. We have HCM, hypertrophic cardiomyopathy, very chunky, excessively hypertrophied heart muscle, dilated cardiomyopathy, also known as heart failure, so a baggy, poorly functioning heart, and also aortopathy, so syndromes and diseases that increase the risk of aortic dissection, so a tear in the main vessel of the body. So individually, these conditions are rare. For example, HCM is 1 in 250 individuals, DCM about 1 in 200, but collectively they're fairly common. And to diagnose each of these and to risk stratify, so know how likely patients are to have complications, we use quite complicated multimodality information. So I'll show you there for HCM. So to properly risk stratify a patient, we need clinical examinations, ECGs, echocardiograms, MRIs, genetic testing. And after all this, we need to think of family screening. All these conditions tend to be autosomal dominant, which means 50% of all the first-degree relatives of someone affected are at risk of also having the condition. And every year, every time we see them in clinic, we kind of look back at the tests that were done over the previous year and use these calculators to broadly predict the risk of having a life-threatening complication. So we manually input data from different modalities into these risk calculators. So what happens in the NHS is that very many patients have the right tests, but in the wrong setting. So they have ECGs or cardiac imaging or CTs of their chest for other reasons, for their gallstones or in advance of an orthopedic operation. And some of these features are not recognized because they're not being evaluated by specialists. And even more frequently, not all the pieces of the puzzle are put together because different healthcare professionals are seeing only snippets of the whole picture. It is therefore very common that these patients are not recognized, that they're lost to follow-up, and that causes a problem for them because they don't reach specialist care, don't get genetic testing, but also for their families. As we just described, these are conditions that run in families, and outside specialist care is very rare that patients are prompted to communicate the risk to the families and get them to come forward. So we don't know how many patients we're missing. And therefore, it's very hard to identify at scale systematically the patients that are best suited in different clinical pathways. So this is what we pitched to NHS England, and we're now part of the Genomic AI network, is can we use AI to allow for near real-time recognition of these conditions, to integrate all this complexity of data across the health records of hundreds of thousands of people at the same time? Can AI support clinical decision-making, prioritize the patients at risk, and keep under low-level surveillance the ones that are not high risk? Identify the patients for clinical trials or specific therapies. Gene therapy is really just around the corner. And build this comprehensive data set of all patients with these conditions, their genetic testings, their test results, so we can be better at predicting their outcomes and enable genomic discovery. So the AI tool that we used is normally named as CogStack. This is a pipeline of natural language processing tools. So basically we have a huge data lake. So all the investigations for patients across King's Health Partners are in this informatic warehouse. So all their test results, all the notes that are written manually in their ward round notes or clinic letters. And what this tool does is it creates structure from this unstructured data. So we train the model to look for very specific concepts. We then validate it, see how accurate and reproducible they are. And at the end, we have tables of structured data, so we are able to have the right diagnosis. We can then have these dynamic, real-time clinical dashboards where we can easily look for patients with very specific genetic conditions or particular features, be able to quickly see what other diagnoses they've been given, what drugs they're on, and from that, be able to refine their risk stratification. So we're envisaging that we'll have this highlighting the patients that are risk and should be seen by clinicians in the near term, and also keeping an overview of the whole cohort to make sure people are having the tests at the right frequency. We're also aiming to identify patients that are unidentified, and I show you here the first pilot that is being led by Alex Deng, which is finding patients that have had aortic dissections and aortic aneurysms. So we basically trained a model to find these concepts. We then deployed the model across all CT scans that were done across the trusts over the last 5 years. We have identified hundreds of patients that have these features, should have been offered genetic testing, but have not come in systematically under specialist care. And in the next couple of weeks, we'll have the first patients coming through clinical genetics assessment to be offered genetic testing. So hopefully in a few months, we'll be able to report the yields of genetic testing and family screening in this first cohort. And we'll do the same for the other conditions I showed you, hypertrophic cardiomyopathy, dilated cardiomyopathy. So in this work package, we're really aiming to show that AI can be used to improve immediately the care of patients. The big problem we're trying to address is most of our patients are unidentified, and also their families. We'll try to improve their outcomes by bringing them to specialist care and offering them genetic testing. And what we're then, in the second half of our project, is building on and refining tools to basically create these dynamic dashboards of risk stratification, and also test is, now that we have access to these very, very complex data sets, can we improve on the risk stratification calculators that we routinely use? Can we do better using AI tools? And these are some of our partners. Thank you very much.
Fantastic work. Thank you so much, Antonio. Next we have Claire Anderson from Unique.
Hello, hopefully my slides are coming up.
Yes,
you see them?
Fantastic.
Yeah.
And we can hear you.
Okay, so good, excellent. Thank you so much for this invitation to talk today about the patient and public voice. And also, I'm actually going to be sitting on the Public Perspectives Forum going forward, which I'm really excited about. And it's just been wonderful to hear about some of the opportunities that AI could bring to us. So to introduce myself, I'm Claire Anderson, and I work for the charity Unique, which some of you may have heard of. We're a UK-based charity, and we support all those affected by rare chromosome and gene disorders associated with developmental delay and or learning disability. And I should probably say at the start that I think, like quite a lot of people, I am naturally quite wary of AI, and I think sometimes I associate it with perhaps more of a dystopian future, which I think was probably how a lot of us were introduced to the technology. But recently, and as I've learned more about the potential it has in things like healthcare, and especially since earlier this year, I actually became involved in a research project which aims to use AI in the work I do. So we're using LLMs, hopefully, to make producing patient-friendly information more efficient. I'm actually, while still cautious, beginning to appreciate just how potentially transformative this technology could be. And I think we really do have to recognize that AI is already here, and as we've seen, being used. And it's actually our responsibility just to make sure that it's implemented in genomics and other areas, but specifically here in genomics in a way that brings most benefit to the public and patients and reduces any possible negative consequences as far as possible. And that's where patient and public involvement and engagement comes in, or PPIE. And the NIHR, the research funder and research partner of the NHS, finds PPIE in research as people sharing their views and experience with researchers to help guide and inform how their research is designed, carried out, shared, and put into practice. It is an active partnership between people and researchers that influences and shapes research with clear examples of what changes have been made as a result of people's involvement, which means that research is being carried out with or by members of the public rather than to, about, or for them. And I have to say that our experience as a charity demonstrates that there really is a very welcome and ever increasing recognition of the importance of ensuring initiatives like GAIN are carried out using these principles in a way that takes into account the public and patient voice. And we know already that the public and patient voice has been used very successfully to shape genomic research already, for instance, in the 100,000 genome projects. And as a charity, we are involved in numerous projects from a PPIE perspective. I could highlight one we're involved in with researchers from Bristol, the sleep detective study. And this has actually had really extensive PPIE engagement from the beginning with parents, with children, with charities such as ours. And they've actually involved everyone in, say, helping develop and test equipment that was going to be used, testing recruitment materials, how the study was actually designed, and also involved in participant recruitment and data collection. But I think that equally, we know that when the voice of the public and patients isn't taken into account sufficiently in research, we know that this can have really potentially disastrous impacts for projects. And I think some of you might have heard about one high-profile example, which happened several years ago, involving a UK-based study of genetics and autism spectrum disorder. That was actually paused following criticism that it failed to properly engage and consult with the autism community about the goals of the research. And really, if there'd been earlier PPIE involvement, many of these problems probably would not have arisen. And so that's where we come on to GAIN and the Public Perspectives Forum. I think that actually, in terms of PPIE, it's actually even more important here than in lots of other projects. We know that the use of AI and genomics marries together arguably the two most high-profile and powerful tools we have, and could potentially revolutionize healthcare. And we've already heard in some of the talks today about the potential benefits this could bring to the public. But it includes allowing conditions to be diagnosed earlier and more accurately. It could help identify and will help identify disease-causing variants, help analyze complex genomic data sets, and also identify potential treatments and hopefully the conditions that will benefit from them. And I think all this means that it actually has potential to touch on each of our lives, not just the smaller groups of people may be targeted by other research or developments. And I think, as I alluded to with my own personal feelings at the beginning, many people are, like me, instinctively skeptical of the use of AI, though, and they justifiably have concerns at how such a powerful technology could be used in their healthcare. And we know already that for members of the public, they worry about things like how it might distort decision-making, the risk to privacy, the potential for hacking of healthcare data, the implications for insurance, and concerns over equity of access to the potential benefits. And I think all this means that public trust that AI is being used in a safe way, that is transparent and fair in genomic medicine, will therefore be really, really important, and maybe even more important than in other areas. And it's therefore just so important that we do have a range of perspectives from people from diverse backgrounds on the Public Perspectives Forum for GAIN. And this should help to ensure that we get a robust framework for how AI should be used in genomic medicine within the within the NHS. And so one area I'd quite like to highlight is equity of access to the advantages the use of AI in genomic medicine may lead to. For instance, and I've very much got my unique hat on here, we need to make sure communities such as rare disease patients are not overlooked, particularly as while individually these conditions affect very few people, actually together they affect 1 in 17 of us. But due to their individuality and how rare they are, historically, rare diseases have been the poor relation in healthcare in terms of recognition and provision. But this is really changing now, and hopefully AI will benefit these conditions as much as others. And so it was really great to just hear from Antonio just now about how this technology could impact rare conditions. I think equally it's essential to ensure people feel the benefits of the use of AI no matter their geographical location in England, particularly as services do vary sometimes within and across regions. And I think finally, just to sort of wrap it up, if I could leave you with one message, it would be how vital it is going to be to take the public with you when it comes to projects like GAIN, which potentially have such far-reaching consequences for all of us. And also, I hope I've highlighted that including the public voice from the beginning of the project should mean that common concerns are taken into account and addressed as far as possible, and will hopefully improve trust from the public that their views and concerns are being listened to. And with this in mind, it would seem sensible to let the public know as early as possible how AI is being used, and also highlight when specific uses prove beneficial. And on a really very positive note, I have to say, GAIN has already demonstrated its commitment to PPIE in a round of webinars, including one that actually involved members of UNIQUE. And these were carried out and run over the past few months to find out more about individuals' thoughts and fears of the use of AI in genomics. So I personally am looking forward to my continued involvement within the Public Perspectives Forum that's been established already as part of this network. Thank you very much.
Incredible. Thank you so much, Claire. And there has been a lot of really interesting insights that have come out of all those engagement sessions. So we're really excited to share those with you once they have been written up fully. So thank you. Thank you.
Thank you.
Who we have next, we've got Alexander Deng, our clinical lead, and he'll be discussing ways in which we can all get involved and next steps. So Alex, I'll pass over to you.
Thank you, Wes. Hi, folks. I'm Alex Deng. I'm a clinical geneticist and the clinical lead for this NHS Genomic AI network. I'm here to talk to you about how to get involved, because we want you for the Genomic AI network, and a network's power is based on the number of nodes and the connections between them. So sorry for the slightly terrifying picture of a recruitment poster for both genomics and AI, but you, the person who's watching this right now, whether it's right now live or on YouTube at a future date, are a very valuable asset for us that we want to get you involved. And here's the 3 ways that we think you are best placed to get involved in this network and contribute to it and ensure its medium to long-term success. Firstly, we'll go through the open call for projects that we're going to put out. Secondly, we talk about 2 stakeholder networks and sort of committees that we're hoping to form, and that's the Adopters and Embedders Committee and a Education and Workforce one. So let's first go on to the open call for projects. Whilst we've talked about some of the pilots that the Genomic AI Network is funding directly under its umbrella, we recognize that there's no chance that we've captured the full scope of activity within the NHS and further afield. To that end, we are putting out an open call for projects. So that is any project involving AI that touches on genomic medicine, we want to hear about it, particularly involving projects that are nearing deployment and evaluation, i.e. nearing close to clinical impact. However, if it's earlier in the life cycle, we're very happy to hear about it as well. And why we want to collect this information is because we want to help you find out where the Genomic AI Network can have input in evaluating your project and perhaps helping it to scale across the NHS. If you scan that QR code there, you'll be taken to the expression of interest form, and that's the interest form for all 3 of these engagement committees / open calls that I'm about to put out. So maybe wait until the end and see which of them, each of the 3 apply to you, and do them all at once. There's a URL there as well if you're not wanting to scan it with your phone. So that's number 1, the open call for projects in Genomic AI. Number 2 is we want to form a group of adopters and embedders who are stakeholders. so that we don't fall into one of the pitfalls of these organizations that are trying to create new standards, frameworks, or toolkits. And that pitfall is, and apologies if anyone's seen this XKCD comic before, but the situation of being many competing standards in a space, for instance, AI in healthcare, and someone saying, ridiculous, we need to develop one universal standard that covers everyone's use case. And the outcome is there are now 15 competing standards. To avoid this pitfall, we want to make sure that our standard is fit for purpose for our users. And the core of that is making it a user-centered design, that we understand where in the workflow or where in the life cycle we're placing this piece of work, a standard or a toolkit or a framework that we're creating, make sure it actually meets user needs, and then constantly be iterating and going back to the user group to make sure that those needs are still being met and we're not going off target and coming back to you 6 months later with a lovely formatted PDF that will be filed away and never opened again in the entire life cycle of your department. So the people we're looking for are anyone involved in the deployment, embedding, or evaluating of genomic AI tools. If you're involved or planning to be involved in that endeavor, you're the right sort of person with this skin in the game who it actually matters to whether we make a good framework. And we want to make a toolkit or a framework or standard, etc. Whatever it is, we want to make something that you want to actually use. And that is the core part of this part of the stakeholder engagement. If you care about us making something that you want to use and inform the process and input into that, please do sign up for this stakeholder group. We're going to be meeting in about 1 month's time and beginning our scoping. So a fairly fast turnaround, and we want to hear how we can shape something to your needs. The third stakeholder group that we're talking about today is workforce and education. And workforce and education is incredibly important because AI transformation projects are digital transformation projects. And we know that most digital transformation projects fail. These are some statistics from management consultancy groups. And we know that most of these failures are due to cultural or skills deficit reasons. This is a survey from government digital transformations, but as another public sector workforce, it's going to be very similar in our workforce, and cultural and skills deficit reasons are addressed through workforce and education solutions. And that's reflected by the survey which has been completed for us and will be published in the near future on the census, as it were, of the genomic AI workforce in the NHS, in that the resources required to support introduction of AI to NHS Genomic services at the vast majority, the top response is that training, knowledge building, and workforce is the #1. Nothing else even comes close to being a bottleneck in terms of how we can implement AI into genomic medicine. So it is a high priority to address and make a plan to take forward. Therefore, if you have an interest in education and workforce for genomic AI, whether or not you have any specific prior experience, but if you're interested in helping us to shape what the future of that looks like and collect, pool, and signpost what we think good resources are already in this space, because we don't want to reinvent the wheel, and then investigate and identify where the gaps are in those resources and begin planning for what new resources might be needed and how we can go about and co-develop that, for instance, with the Genomic Education Program. We would love to hear from you, and do scan that QR code and put that in your expression of interest. We'll be meeting in early 2025 with that stakeholder group to make sure we get the ball rolling, and all the outputs of this education and workforce piece will be going onto our website and publicly available. So for instance, if we create a collection and signpost of good resources, that will be, we'll work in the light in transparent methods to make sure that it's accessible to as many people as possible with as little friction as possible. just another word on staying up to date, you can email us on our direct email, which is gstt.genomicainetwork@nhs.net. You can join our mailing list through that same expression of interest document, and our website is up and running. It will be populated with more of our materials as time goes on. And last of all, that LinkedIn QR code, which has been lurking in the bottom right corner of this whole presentation, do feel free to join that, as well as we'll be announcing our new initiatives, publications, collaborations, etc. What that leaves me to do is go to my last slide, and we can now begin the Q&A, and I'll leave that QR code in case the fancy takes you to scan it and put in your expression of interest in being a part of the open call or either of our stakeholder groups. Thanks very much.
Fantastic. Thank you, Alex. So we shall dive into the Q&A session. A big thanks just to everyone all the speakers have just presented. Please do, if you have any more questions, keep posting in the chat. We'll keep reviewing them as we go through the session as well. We have a couple broader questions, which I think might be a good place to start, and then we can dive into the to maybe some of the detailed questions. So Debbie, I believe you're still around. Let me just double check quickly. I think you're around. If you are,
Yeah, I'm here.
So it's a question around I think around the unified genomic records and the
Yes.
wide data digital program. But it's basically the question is, can you please specify whether you mean laboratory data, clinical genetic data, or both? Integration of data from the clinical genetic services across the country might benefit from a shared digital strategy. And how can this be achieved when individual trusts are making separate decisions on digital tools, etc.?
Okay, so the answer is it's universal. A single patient record for any genomic data across England. It is a concept at the moment. One of the big barriers to delivering the concept is information governance. So because we've got the ear of privacy, transparency and trust in NHS England. We are moving forward, first of all, with ministerial direction to begin to share data in a different way. But the likelihood is we will need legislative change, which could take 2 years. But technology, we are building anyway, and the idea is that we will be able to share those data in a standardized format, because what we will be using is an interoperability message called FHIR, as I mentioned earlier, and hopefully bring everybody up to the same standard to be able to communicate with a central broker behind the APIM layer in NHS England. So it will be a national service. There are some barriers to get over first.
Fantastic. Thank you, Debbie. I think it's really helpful just setting the scene as to kind of the landscape and kind of where AI fits within that a little bit. So I guess I might open up the questions here to James and Alex. What is the main purpose of, and Sarah, actually, please feel free to jump into this, but what's the main purpose of the Genomic AI Network in relation for researchers? Is it around providing funding? Is it around fostering collaboration, enabling quicker and broader access to data? If so, what platforms or what else might it be aimed at?
Thanks, Wes. Happy to have a go, at least to start this one off. I think the question of funding, obviously the existing pilots we're running required funding, and that was sought via NHSE. If there's further projects that come to our attention, we can look to collaborate in the future, but we don't have any immediate funding right now for additional projects. But that's something that we will certainly review over the lifetime of the network. Certainly, though, collaboration, absolutely. I think that's kind of the absolute kind of one of the key goals of the network, is that we want to understand people's requirements and help build something which kind of help accelerate adoption of AI. So collaboration, I'd say above all, is like one of the kind of the key goals of the network. Not sure what else Wes was in that question, sorry.
No, that was basically it. It was just asking in the ways in which the network plans to incorporate researchers. So I think it's a good answer for the time being as we develop as well. So I guess going into some specific questions around some of the projects. Antonio, this question is related, I think, slightly towards your work package around, are there any plans on including multimodal data for AI development alongside genomics data, such as medical imaging?
Yeah, so at present, we're using mainly the tools that are ready to be translated, which is natural language processing. So looking into imaging reports and all the data that goes into it. We now have a stretch pilot, which is using the ECG raw picture, so the squiggly lines, not just the text report. And definitely that is the way we would like to go, is to incorporate all different types of multimodal data, including imaging, including not just the genomic reports, but also the genetic data. But that is quite a complex and quite large scale ambition. So at present, we're mainly focusing on notes and text rather than the raw images.
Thank you, Antonio. Sorry, just battling my mic there. And another one related to your work package. And then Sarah, we've got some for you as well coming up, so stay tuned. But pediatric ICC services are currently swamped by well children who are having regular echoes due to lack of risk stratification. Could your tool be used to utilize echo data and genomic variants to make predictions to guide the frequency of echo screening on an individual level, therefore reducing demand?
Right, that's really one of the key aspects of what we haven't focused on pediatric just because of the team that was involved in the project are all adults, but it's very much a proof of concept, and that's what we would like to do. Our risk stratification is really poor nowadays, and it really seems that we have so much available data that we could do better. So at one end, for example, I'll talk in cardiology terms. Most patients that we put cardiac defibrillators because we think their risk of sudden death is very high, those defibrillators are never required. And at the other hand, quite a big number of people that die suddenly with known cardiac disease were deemed to be low risk and do not have a defibrillator. So that's just one of the things we need to do better. So having at scale data across all our trusts, but hopefully across the whole NHS, millions of patients with lots of data points and lots of clinical outcomes that individually are rare, but at an NHS data will be very large. That's the ambition, is improving risk stratification and do it dynamically. And again, try to get the balance of increasing follow-up for the higher risk, but also try to improve efficiency through the system of the patients that don't need to be seen as frequently. A lot of what we do nowadays is seeing patients yearly, because actually most of the ways we book patients into clinic can only be done at 12-month intervals. That is definitely not the right way. So yeah, from the research point of view, and also from clinical decision making and having these AI assisted pathways where we could kind of feed in patient data, but also their family history, and dynamically bring them to specialist care or remain in low surveillance pathways seen every few years, allowing also patients to interact. So report symptoms is definitely not the right way to see patients every 12 months and ask them, have you had palpitations? If they've had palpitations 11 months ago. So having a system that is enabled at scale to digest all this data is where we want to go.
Fantastic. Thank you, Antonio. All right, so Sarah, we have a question for you. And it's relatively broad, but an interesting one, I think. How do you plan to deploy the tool within the NHS? So how do you actually plan to deploy it?
I managed to unmute first. Yeah, so GenePy, the way we've been using it so far is we need, very much like we need Nomad or any population repository to say, well, this variant is common in the population, this variant is rare in the population. The first thing we have to do is sort of get a reference database. So we need to know for any given gene, what's the profile of scores? And there's some genes in our genome that are quite prolific. They allow lots of mutation. It's possible to accrue a really large score, and a really large score means you're completely healthy. There are other genes in the genome that are critical to function for health, and they're very restricted, very conserved, and a fairly modest score can be indicative of risk to develop congenital disease. So what we first need to do is develop this database, and obviously the Genomics England data, 100,000 genomes data, and increasingly the Genomic Medicine Service data allows us to build up a repertoire of what does the pathogenic burden across all genes for a increasingly diverse large population of humans look like. And then once we've got that database enabled, it's possible to take N of one, just one new patient that's parked up in front of a consultant saying, I've got these onset of symptoms. I think it might be a genetic disorder. We can sequence that individual, generate their scores, and ask for in the genome, where does this patient have extreme scores? Where are they an outlier with respect to their with respect to their genomic profile? And then cross-reference that with the phenotypes we see in that individual in order to very quickly point to the genes in which this individual is an outlier and in which there may be the causal diagnosis. So that's what we've already done as just a pilot preliminary data in Genomics England. It was not targeted to any particular clinical area. It simply looked and asked, for individuals with a negative diagnostic report, where do they have extreme signals? Do those extreme signals coincide with genes that are plausibly related to the phenotype? And that's what helped us uncover hundreds of misdiagnoses. So that's ultimately how we end up using it. But it requires and demands that we have a reference database, and that's representative of the entire UK population. So we need to test that it's safe and it does represent all ethnic diversities. But that's how we see it being deployed over the next coming years.
Fantastic. It's very exciting. So thank you for the update. Thanks, Sarah. Just a quick one, because there's been a few questions around this relating to the slides. So it's a bit logistical. The slides and the recording are going to go online. They're going to be posted on YouTube, and we will share the link back with everyone. So everyone should have access to this, the chat as well, and the presentation. So that will be coming up. In terms of best way to stay updated with news and events as well, has also come out. We do have a LinkedIn, as Alex has mentioned. In our communication back with everyone after this, we will put all the details in terms of how to stay involved. So, so that will come out with a follow-up email for sure. Okay. So a question around PPV, so patient and public, and it's a question to everyone in the panel and all the organizers. Where does patient and public fit within the management structures, and how do we get patient publics involved? And specifically a question for yourself, Alex. Are they required to join the network? And if so, how could someone express their interest?
I guess I'll start with that. It's a little bit of a separate question from the QR code and the expression of interest form. That's, I guess, more enfranchised stakeholders from the technical side of things. The patient and public involvement part of the network has been already running for 6 months. They've had engagement sessions, I think at least half a dozen now, and that is led by our colleague Anwar Al-Haq from KCL. So in answer to that question, the PPI panel is ongoing. If you specifically want to be connected to ask questions about that, you can direct queries to the generic email address, the gst.genomicainetwork@nhs.net. And I see that Tony's in the audience as well, who's part of this panel. Tony, we can allow microphone for him. I'll let you take it, as this is your domain, Tony.
Thank you, Alex. Yes. Yes, we've done fantastic work, and I think some of the 200 people on this call are hopefully some of the 100 that we have had in 10 patient engagement things so far. Basically, we gave them an outline to start with and of what the whole GAIN project was about, and then asked them a load of questions. And it was facilitated fantastically by Nikki Scott from the East Genomic Medicine Service. A report is going to come out. We have something like 20 people who've indicated their wish to sit on our PPI panel, and that we will instigate as soon as we can. And as all the work packages produce results and things, those will be fed back to the patient panel to see what they think about it and get their views. So it's very much front and center from the outset. Thanks, Alex.
Thanks very much, Tony.
Thank you. And there was a similar question around how can charities get involved, potentially through some of our stakeholder engagement groups. There's a route through that, but also through the PPV panel. So there are multiple avenues. We will also be communicating this, so it'll all come out as well. But there's definitely a route for charities, and that's through our groups as well as the forum. Now, a question around, again, it comes back to the specifically in a research setting, but if someone has a model and they that actually accurately predicts risks for a particular disease, what's the path for them to implement this into the NHS, and potentially how is GAIN trying to support that? And James and Alex, that's a question for yourself.
I can be frank and say there is no standardized path, and that's partly the point of why the Genomic AI Network exists, because there's a lot of working in silos right now in the GLHs and GMSAs, and both the laboratory and the clinical side. There is no standardization of processes. There is no user guide on how to do this. It is the job of this network to work with its enfranchised stakeholders to find the best path to that and make something that works in terms of a toolkit, a standard, or a framework. So that first question is in the future, and if you'd like to help shape that conversation, do put down your expression of interest. Was there a second part? I forget.
No, that's okay. Thank you. Yes, no, that you answered the question. Thank you, Alex. I'm trying to manage multiple screens here, so it's slow to answer, but you did, so thanks. Again, a question around similar to the fact that there's potential tools out there and people who are wanting to engage and get avenues in. On a somewhat similar side, there's a lot of people who are keen and engaged and want to do stuff and want to apply it, but don't necessarily have the ability to find it, or they don't have the time to find it. So they've asked essentially, will GAIN have a mechanism for matchmaking projects so that people can find out more about what's out there? And also just similar comments around, it'll be helpful to see a summary of different projects to raise awareness and spark consideration. Don't know, James, whether you want to talk about some of our plans around the use cases.
Yeah, absolutely. I mean, I think honestly, the aim of the network is to be aware of every AI use case relating to genomics in the entirety of England. That's kind of where we want to get to in the relatively near future. So absolutely, I think we kind of hope that the network is able to kind of bring people together in that respect. In terms of kind of the matchmaking side, I think this is probably where the stakeholder groups that Alex outlined are the kind of the best forum for that. So where people kind of have an interest, but maybe don't have the kind of particular capacity right now to do it themselves, hopefully through those groups, we'll be able to kind of bring groups together that can actually kind of talk about particular use cases and then how they might be deployed more widely.
Thanks, James. Now, a question actually that I didn't spot before, so I should have probably mentioned it there. But Debbie, it's coming back to you and coming back to the wider setting. And there was a question about whether what we're doing is linked to the FDB program, and or there's also mentions of SDEs and how it all links.
Okay, I can reassure you that absolutely we are talking to the broader NHS data and digital program leads in the Transformation Directorate. So particularly FDP, the Federated Data Platform, we're working with. We've actually got a pilot, a proof of concept running with them, which started a week last Monday. So yes, the central genomics data and digital program are working with FDP. In terms of SDEs, yes, there are a series of conversations going on, and I actually do sit on the Data for R&D program board. But potentially, yes, SDEs could be used for research for genomic data and any other match data, imaging, etc. in the future. Equally, the Genomics England NGRL and the Trusted Research Environment is a similar sort of environment. So equally, they could be used for research studies in the future as well.
Thank you, Debbie. Thanks for clarifying. Sarah, another question has come up for yourself. It's come a couple of times now and it's similar. So for GenePy, is there a reason why, and apologies, it's an acronym, CADD was used in place of another tool such as Rebel?
So yeah, we did look at, we actually, in our initial deployment of GenePy, we tried about 17 different pathogenicity, deleteriousness metrics. That there's many of them, and they're emerging all the time. And we are in no way devoted to any one metric. We use CAD 1.6 at the moment simply because it scores both coding and non-coding variants, synonymous and non-synonymous variants. There's a number of different tools, and it can be adapted. So we make the code available on GitHub, and it's entirely adaptable to any different score that a user might define. So if your particular focus was splicing only, you could exchange it for Splice AI if that's what you wanted to do. But CAD actually incorporates Splice AI. It's a machine learned in silico metric itself. It's the one that we find most useful and sensitive at the moment, but it is by no means the only one that can be used, and it's not necessarily the only one that we recommend. And as I say, the pipelines are available, and you can simply switch in or switch out those different in silico metrics as you would choose. So that can be user defined.
Wonderful. Thank you. Now, I'm conscious of the time, and I want to make sure that James has an opportunity just to wrap up for everyone. Now, we haven't been able to get through all the questions, so we apologize for that, but we will have a look at that afterwards and see what themes we can pull out and how we might be able to answer those for everyone. So firstly, just thank you for posting the chat. It's been a really interesting conversation. There's one question that I might just quickly answer, which is around whether we plan to get opinions from other regions across England, and absolutely, we're a national network and absolutely plan to make it a national program and make sure that kind of the work we're doing is reflective of the entire country, as well as hearing from other areas such as Wales. I think there's a question around whether we work with Wales and other countries. So absolutely. But I will hand over to James for a little quick wrap up.
Thanks, Wes. And yeah, actually, I would reiterate that. I think the network is very keen to engage with stakeholders from across the nation. We are certainly not going to be just sort of sitting down here in London permanently. We're going to be out and about across the country, both physically and also across the different stakeholder groups. And I think the main thing to say is thank you so much for all our speakers today. Really interesting set of talks. Hopefully the audience now has a better idea about what the network's all about and what we want to achieve. And I think that the main thing to say is, we're really keen for volunteers here. Like, obviously, the entire point of the network is to bring stakeholders and the collaborators together. So we're never going to achieve our goals if we don't have people to work with from across the NHS, industry, academia, charities, and beyond. So please do, if you've even got the slightest interest, get in touch with us, and we'll figure out a way to work together through the next year or so. But I think that's probably it. So thank you very much. And as Wes mentioned, you'll be able to kind of get a recording of this on YouTube and LinkedIn after the event. But I'll say goodbye. Thank you.